Welcome to Eagles Concept Learning Room. We continue with solutions for 8 November 2018 Science Paper 2, which is Chemistry, Section C. Now, Section C has got 3 questions. You are only supposed to answer any 2 questions of your choice in a separate answer booklet that is provided for you. So choose any 2 questions of your choice, but since we are just teaching, I'll go through all the 3 questions to explain the concepts involved and also just to help you on the particular topics that came so that you may be victorious in your forthcoming exams. Okay, so C1, the diagram below illustrates a laboratory preparation of ammonia. Okay, so ammonia can be prepared in the lab. It can also be prepared in the Haber process. So the commercial preparation of ammonia is known as in the Haber process. Now here in the laboratory, this one we just prepare it at a smaller scale. Okay, so now this is how the setup looks like. Okay, so in the setup here, you need to have heat. Now this heat, there's a mixture of ammonium chloride and the calcium hydroxide. So calcium hydroxide and ammonium chloride, and then make sure that this flask that you are heating in, it's slanted. Okay, so make sure that this one is slanted. Why is it slanted? To avoid steam from boiling water from returning into this boiling flask here, because if steam went backward here, it can cause an explosion. So you have to make sure that this one is slanted. So in case they asked you, why is this flask slanted? So the reason is that it is to prevent the backward flow of the vapor from the boiling water steam. All right, so what happens is when ammonium chloride and calcium hydroxide, they mix together, they are heated, they are going to produce ammonia, calcium chloride, and some water. So those are some of the products as you see in the equation. Okay, then here we've got this one, the one which we call here we have the X here, we have to put what we call calcium oxide. So we put calcium oxide. Now calcium oxide, this one, it serves as a drying agent. So it has to dry the gas here, and then the gas is going to be collected right here on top by a method called downward displacement of air. And it is collected by downward displacement of air because ammonia is less denser than air. Now ammonia cannot be collected on top of water because ammonia is soluble in water and can easily dissolve, and it will be difficult to separate it. So those are some of the things that you should be able to know about this laboratory preparation of ammonia. So question A reads, construct a balanced chemical equation for the reaction being illustrated in the diagram above. Okay, then B says state the common name of substance X. Now for you to know the common name of substance X, you first of all have to know its name. So it's calcium oxide, and the common name is actually slacked lime. Okay, so what is the purpose of substance X? Like I said, this one is a drying water agent. All right, so they are asking, why is ammonia collected by using the method shown above and not above water? So you need to give 2 reasons here. So the above method is downward displacement of air. So you can say ammonia is collected by downward displacement of air because it is less denser than air. So then the second reason you say is ammonia is not collected above water because it dissolves in water, meaning it is soluble in water. All right, then describe the chemical test for ammonia. Now ammonia is basic in nature, so you can easily use a litmus paper to test for the presence of the gas. Ammonia has got a lot of uses, amongst which is in the manufacturing of what? Explosives. All right, let's see how you can tabulate your answers very well. So the first one here, the equation, make sure it is balanced. Like I said, ammonium chloride will react with calcium hydroxide, so it will give us the ammonia gas, then it will give us calcium chloride and the water. So these are the 3 things that are produced, and you just have to memorize these things. Now you can memorize ammonia is produced, but this calcium here and the chlorine gives us a salt, then the rest they give us the water. All right, so the second one, they were saying Substance X is actually calcium oxide, and its common name is the quicklime. So the common name is quicklime. So we have also what we call slacked lime. I think slacked lime is calcium hydroxide, then quicklime is calcium oxide. All right. Then the other reason, we said quicklime is used as a drying agent, which has already been explained. Then ammonia is collected this way, meaning downward displacement, because it is lighter than air, 1 mark. Ammonia is not collected above water because it dissolves in water, another 1 mark, and you collect your 2 full marks. All right, then this is a description. So you can put few drops of ammonia gas on a red litmus paper, which is going to turn to what? Blue, because ammonia is actually a base. So bases, they change a red litmus paper to blue. Okay. Uses of ammonia, the major one is in the manufacture of explosives, but we can also use ammonia as a cleaning agent. We can also use ammonia in the manufacture of fertilizers. There are some fertilizers that we use, there's ammonia in there. And we can also use it as a refrigerant for plants, All right, let's go to C2. C2, the question reads, both fats and proteins are natural polymers. Both fats and proteins are natural polymers. Name the synthetic polymer that has the same linkage as the fats, proteins. Now, let me just give a comment on this one so that we can even revise. I always advise organic chemistry is a very important aspect of the exam. Please revise and know it. Okay, so first and foremost, we've got what we call polymers. So now, when we are talking about these guys called polymers, so polymers are simply giant molecules that are made by joining smaller molecules known as what? Monomers. So these polymers, they can be in two broad categories. There's what we call the synthetic polymers, also known as the man-made polymers. So we have what we call the synthetic polymers, also known as the man-made what? Polymers. So synthetic is man-made. So there are two ways in which we can make these synthetic. So number one, we can make them by using what we call addition polymerization. So there is addition polymerization, where we add similar monomers together to come up with a giant. Then there is also what we call condensation polymerization. So we call it condensation polymerization. So these are the two ways in which you can make it. These the synthetic polymers or man-made. So there are two ways. There is where we use addition polymerization, and we use addition polymerization on simple things such as the polyethylene, polyvinyl chloride, polypropene, and so on and so forth. Then there is this part here for the condensation polymers, and we have two main types here. Two main types for the condensation polymers. We have got a guy called nylon. So we have got a polymer called nylon. Okay. Then we also have another polymer called terylene. So we have nylon and we have terylene. Okay. So these are the two that we have. If you can master them in the same order that I'm saying, it will even help you. So we've got nylon and terylene. So now nylon, this one, we have what we call, so the monomers of nylon, we have what we call a diamine. So a diamine is basically, it will look something like that, where we have N here, then we have an H, okay, H and H there. Then even this side also, we have another amide group, which makes it di to become 2. Okay, so this is the diamine and a dicarboxylic acid. So these are the monomers of nylon, and we also have a dicarboxylic acid. So a dicarboxylic acid, it will look something like this. A dicarboxylic acid will look something like this. Okay, this is the carbon chain. Then here also we are going to have another carboxyl group like that, and OH. Okay, so like that. So these two now, they are called condensation polymers because during their formation, actually, they lead to the production of a water molecule. So what happens is that this H here and this OH, they react. And when they react, because there is two hydrogen, H2 and an O, so this one will be eluted, will be produced as the water. So water will be what? given out. So because these will react, they will combine now and form a linkage, which will be like this. Okay, so this N and one of the H has remained. So this N will connect directly to the C here, which will go like that. So this is the C here. Then we have the O, and this bond here which forms, this is the bond that joins the two. This one is what we call the ester the amide linkage. This one is known as the amide linkage. Okay, so this one is the amide linkage. So this one will be called the amide linkage. That is the name of the bond. Then for the pteryline, this one has got what we call a diol. So a diol will just look like that, HO. Then we have a carbon chain, okay, a carbon chain, and another hydroxyl there. Then and also a dicarboxylic acid. So we have to master these things. So these are the monomers, okay, and a dicarboxylic acid. So this is a dicarboxylic acid, just like the way it has been drawn on top there. Okay, this is a dicarboxylic acid there. So that is what we have. Okay, so these ones also, they are going to react expelling a water molecule. So if we can get one H from here and this OH here, they react. So what we are going to have is we're going to form something like this. This O here will remain. Then this O will directly connect to the C. So this C here, that is the one there with a double bond of CO here. So this linkage that we have formed here, this is what we call an ester linkage. So this one is called an ester linkage. All right. So this one is an ester linkage. So please let us remember this information. Now, apart from that, we also have what we call now the natural polymers. These are as a result of God's action. Okay, this is an act of God. This is a creation of God. These ones, man-made, it's us who makes them. But these ones, the natural polymers, we can talk about. Number one is the proteins. Okay, so proteins are natural polymers. Okay, so we have proteins. That is the first group of natural polymers. Then we also have the fats. Okay, so we have the fats. And finally, we have the carbohydrates. So these are the three natural polymers that we have. Okay, carbohydrates. Now, carbohydrates, the monomers of carbohydrates, they are very simple. These are the diols. Okay, diols are the monomers. Then for the fats, it's fat acids and glycerol. Those are the monomers. Then for proteins, it's amino acids. So this is why we are saying proteins, the type of bonding in proteins, it resembles the what? It resembles, so proteins, they resemble nylon. Okay, protein and nylon, they have similar bonds. Okay, they are both the amide. Then the fats, they have got an ester. So fats can be likened to what? To pteryline. Okay, to pteryline. Then carbohydrates are the ones that are on their own. Them, when they join together, they form a type of bond known as a glycosidic bond. All right, so that is a little bit of the information that you are supposed to know here. And remember, when we talk about the natural, the man-made polymers here, they've got an effect. They are non-biodegradable. So non-biodegradability simply means that they cannot be decomposed by bacteria. Okay, that is one thing about them. So that's why they encourage recycling. All right, brief history about these things. Now let's answer the questions. So name the synthetic polymer that has the same linkage as the fats. So the same linkage as fats. So here definitely we are talking about what? Pteryline. Okay, so the synthetic one here, we said which one? Okay, so fats and pteryline. So it's pteryline. So you just have to remember this one from my explanation. It's pteryline. Then the proteins, this one it's nylon. Okay, so that is the way it is to be. So here it is what? Nylon. Okay, draw the type of linkage found in the synthetic polymer named in A1. So fats, we have just drawn. This is the one that is here. Okay, then synthetic polymers are non-biodegradable. What is meant by this statement? Okay, we've just defined that one. Let's see how you can properly write the answers. Okay. There is also C. Okay, let's go to C. The structure displayed below is another natural polymer. So when you look at this one is a carbohydrate. This one. How do I know? Because a carbohydrate, we said it has got something like this. Let me just remind people. So here we have got an HO. Okay. Even this side we also have OH. Okay. Then it is reacting with another one, which will be like that. Okay. Another one which is similar like that. Okay, so what is going to happen here is very simple. We are going to get this HO here and one H to remove as water. So when you remove that one, you are going to remain with this one straight double bonded to this one. So if you add another one from here, again it will continue like that, and so on and so forth. So that is how come we know that this one is a carbohydrate. So name this polymer. The answer is carbohydrate. Is this polymer an addition or a condensation polymer? So the answer is that this one is a condensation polymer because it involves the removal of water. Okay, when two monomers are joined together, water is removed. Okay, then they are saying draw the structure of the monomer used to synthesize this polymer. So I just drew what I'm supposed to draw. So I just drew, this is the one that I first drew here. So you just draw this part there. Okay. Then what type of linkage is found in this polymer? So we say it's a glycosidic what? Linkage. All right. So the answers are there. We have pterylene, just like we said. Okay, just like we said here. We have pterylene, nylon. So we have pterylene there. We have nylon, and this is the ester linkage which has been drawn. Then we have the carbohydrate, and the reason is there. This is a condensation polymer because a water molecule is given out when two monomers join together. Okay, and this is the drawing that is here. So this is the drawing, and the name of the linkage is a glycosidic linkage. Okay, let's go to C3, and this one will mark the end of our discussion for this particular session. C3 reads, aluminium oxide reacts with both dilute hydrochloric acid and sodium hydroxide in the presence of water. So aluminium oxide reacts with both dilute hydrochloric acid and sodium hydroxide in the presence of what? Water. So now, what term is given to such an oxide that behaves like aluminium? Now, aluminium here, it is reacting with both what? The acid and also sodium hydroxide. So such oxides, now remember, let's take a quick history about the oxides. So we can talk about oxides. They are, okay, let's just write this, oxides, okay. There are three, is it 3 or 4? Let's list them, then we are going to decide. So number one, we've got what we call the basic oxides, okay, basic oxides. Then number two, we've got what we call the acidic oxides. Then number three, we've got what we call the neutral oxides. Then number four, we've got what we call the amphoteric, okay, amphoteric. Okay, now basic oxides are oxides of metals. Remember on the periodic table, metals, when they burn in oxygen, they produce what we call basic oxides. Then acidic oxides are oxides of non-metals. When non-metals burn in oxygen, they produce acidic oxides. Then neutral oxides, these are the oxides of elements such as hydrogen and so on and so forth. Then we've got amphoteric oxides. These are basically the oxides of the metalloids. Mostly the metalloids are the ones that form these ones. Now the behavior of these is that the amphoteric oxides, they react both with what? They react both with an acid and with a base. So that is one thing that you should know. Amphoteric oxides, they react both with an acid and with a base. So here we are talking about oxides of lead, oxides of zinc, and aluminium, and so on and so forth. So the neutral oxides, they don't react with anything. Okay, so having that background, now we can answer what term is given to such an oxide that behaves like aluminium oxide. So it's amphoteric. Okay, State another oxide that behaves in a similar way like aluminium oxide. So we have also mentioned that one. Then state the type of a reaction that occurs between aluminium oxide and dilute hydrochloric acid. So the type of a reaction here is actually a neutralization reaction in which water and a salt only are produced. So you'll see how we are going to construct a balanced chemical equation very soon. Okay, so let's construct a balance. So here we are saying the first answer was amphoteric oxides. Then we have zinc oxide, lead oxide, and so on. So these are examples of amphoteric oxides. We have lead oxide, zinc oxide, aluminium oxide. Those are the major three. So let's remember these things. Okay. Then it's a neutralization reaction, and the equation is as follows. Make sure that the equation is balanced and it has the state symbols. So aluminium oxide plus hydrochloric acid will always give us aluminium chloride and water. So this equation is what? Balanced. All right. So aluminium is used in overhead electric cables because it is a good. Now let's look at this question. It's a very interesting question. They are saying state two uses of aluminium and the properties on which the use depends. Okay, so this is how come we are saying to write this one. We are saying aluminium is used in overhead electric cables because it is a good conductor of electricity. So you are not just writing the use, but you are also telling us why is it used that way. So that's why we are saying used in overhead electric cables because it is a good conductor of electricity. The second one is that it is used in making cooking utensils because it is a good conductor of heat and it is resistant to heat. Okay, meaning heat does not easily destroy it. It is also used in food wrappers and drink cans because it is resistant to corrosion and it is not what? Toxic. So they just needed two. Any two answers of your choice here would make sense. Okay, so there is this last question here, and the last question says carbon dioxide and water belong to two different types of oxides. State the oxide, state the type of oxide to which each of them belongs. So now we are saying carbon dioxide. Carbon dioxide, is it a metal or a non-metal? Think from the look of things, it's a non-metal, so it's an acidic oxide. Water is a neutral oxide. Okay, so you write your answers clearly. Carbon dioxide is an acidic oxide and water is a neutral oxide. All right, so we have come to the end of 2018 November chemistry, which is science paper 2. Thank you so much for listening. Don't forget to subscribe if you are watching for the first time. We are uploading a lot of content just to help you in the exams. Thank you so much. Share with your friends and see you next time.